All right, 67, pretty much same as 66. Yay, calculus. Go one by one. Evaluating the derivative at x equals -1. Derivative of f of x is going to be 3 f prime of x minus g prime of x. Evaluating, that's going to be 3 times f prime of x at -1 is 2 minus g prime of -1 is 1. 3 times 2 minus 1 is 5. B, derivative of f squared of x times g cubed of x. So we need product rule and power chain rule. So we have the first times the derivative of the second. It's going to be 3 g of x squared times g prime of x plus the second times the derivative of the first. It's going to be 2 f to the first of x, f prime of x. Product rule, power chain rule. No, just go ahead and run through f of when x is 0. So f of x is -1, squared is 1 times 3. G of x, or g of 0, is -3, squared is 9. G prime of 0 is 4, plus g of 0 is -3, cubed is -27. F of 0 is -1. F prime of 0 is -2. 3 times 9 times 4 is 27, 54, 108. Minus, minus, minus makes a minus. 27 times 4 is 108. 0. G of f of x, where x is -1. So the derivative of g of f of x is just chain rule. So it's going to be g prime of f of x times the derivative of the inside is f prime of x. Evaluating, x equals -1. F of -1 is 0. G prime of 0 is 4 times f prime of -1 is 2. Equals 8. Do similarly here in D. F of g of x is going to be f prime of g of x times the derivative of the interior of our function, which is just g prime of x. Evaluate this at -1. G of x, so we'll rewrite the whole thing, see if this sinks in. G of -1, g prime of -1. So g of -1 is -1. G prime of -1 is 1. F prime of -1 is 2. It's 2. Let's see, that's E or D, E and F yet. E, we have f of x of g of x plus 2. Quotient rule at the bottom. Times the derivative of the top. Minus the top. Times the derivative of the bottom. All over bottom squared. Let's go through some evaluation here. And E was being evaluated at x equals 0. x equals 0. So g of 0 is -3, plus 2 is -1. F prime of 0 is -2. F of 0, -1. G prime of 0 is 4. G of 0 is -3 plus 2 is -1 squared is 1. All right, so the bottom goes away. -1 times -2 is 2. Minus -1 times 4 is -4. All over 1. 2 minus -4 is 6. Polishing off 67. We have F, which is G of x plus f of x. Well, that derivative evaluated at x equals 0. All right, looks right. All right, this f, well, f in that parenthesis, you're just misleading. So here's our f, which is g of that. All right, so chain rule. Derivative of g of x plus f of x is going to be g prime, our original interior, times the derivative of the inside will be 1 plus f prime of x. All right, so it's the derivative of the inside plus the derivative of the inside. Kind of redundant, but we'll deal. X equals 0. It will be 0 plus f of 0, which is -1, times 1 plus f prime of 0. G of -1, oh sorry, g prime of -1, excuse me. G prime of -1 is 1, times 1 plus -2 is -1. 1 times -1 is -1. $68. You'll be looking around here somewhere. Where is 68? Find the value of dWds at s equals 0 if w equals sine of radical r minus 2 and r equals that. That's not too bad. I'm just doing parts. All right. So 68. We are given in 68 that we're looking for dw ds. So that's the derivative of w with respect to s at s equals 0. We're given that w is a function of r. And r is a function of s. That's right. All right. So w is a function of r is a function of s, w is a function of s. We are aware that the dw ds is equal to dw dr divided by dr ds. This is the same as we had before with dy dx being dy dt and dx dt. No, it isn't. Yeah, well, this will invert. Yeah, so dw dr and dr ds. No, we don't want to do that. I'm sorry. That's incorrect. That's incorrect because those won't cancel. We'll wind up with dw ds dr squared. dw dr times dr ds is more what we're looking for. Now these two cancel. We have dw ds as we're looking for. So derivative of w with respect to r, derivative of r with respect to s. That's how we need to set it up so that they cancel. If we had s in terms of r, that would be a division. So dw dr, derivative of w with respect to r is going to be right here. So that's going to be the cosine of the square root of r minus 2 times the derivative of the inside by chain rule. It would be 1/2 r to the negative 1/2. And derivative of r with respect to s is going to be 8 times the cosine of s plus pi over 6 times the derivative of the inside with respect to s, which is just 1. We're good there. So now you need to multiply these two. So we have dw ds. Well, actually, we don't have to multiply all this out because we want it at s equals 0. So we can just evaluate each one of these individually at 0. So dw ds evaluated at s equals 0 is the same as dw dr evaluated at s equals 0 times the derivative of r with respect to s evaluated at s equals 0. Let's evaluate dw dr at s equals 0. So we want to put this when s equals 0. Pity there's no s in it though, but we can find out what r equals when s equals 0. So we're going to put in our original equation. S equals 0 means that we have the sine of pi over 6. Sine of pi over 6 is 1/2. 8 times 1/2 means that r equals 4. Go ahead and put in 4 there and a 4 there. So our derivative with respect to r when s equals 0 is the same as derivative with respect to r when r equals 4. So now let's evaluate derivative of w with respect to r at r equals 4. So that's going to be the cosine of square root of 4 is 2. 2 minus 2 is 0. 1/2. 4 to the negative 1/2 is going to be 1 over the square root of 4. So that is cosine of 0 is 1. Square root of 4 is 2, so 1/2 times 1/2 is 1/4. It's 1/4. Now we'll take the derivative with respect to s of r and do that while s is 0. So that's the cosine of pi over 6. Cosine of pi over 6 is radical 3 over 2. Radical 3 over 2 times 8 is going to be 4 radical 3. And the 4 and the 1/4 cancel. And so we have the derivative of w with respect to s when s equals 0 is radical 1/3, or radical 3.